Wonderful to be here. I don't know what that Kerala startup mission was. Yes, I think we are very happy to represent the startup world in the nation. My name is Geetha, and I'm actually a computer scientist turned entrepreneur. Inspired by the previous speaker, though I did not plan before, I thought I'll tell the story of how Niramai started because it may be interesting and may connect with the previous speakers' inputs and then go into what Niramai itself is. So I have a PhD from Indian Institute of Science, incidentally the same alma mater, in computer science. And I've been working with different organizations like multinational research organizations like Hewlett-Packard Labs, Xerox Research, and also our own CDAC, Center for Development of Advanced Computing, which where we came up as a team with the first supercomputer long ago. But when I was working on these AI-enabled solutions for healthcare, transportation, customer care, and business as usual, also trying to see what businesses can do with AI 5 years down the line, 3 years down the line, and trying to innovate new solutions, I had a very serious personal experience with my very close cousin, sister. She was late 30s, and she got detected with breast cancer. And it kind of suddenly stuck. You know, breast cancer was like very far away, and suddenly you see very, in a person very close to you. And she had a small son, and he was going to 8th standard or 7th standard or something like that. And so he was like stuck. He was a brilliant boy. He used to be on the first page of the school, souvenir book because he was so bright in everything and all that. And I saw how the whole family went into a wreck just after hearing that news. Within 2 years, she was no more. So it was a huge shock for me. And I was a scientist, so I started, of course, reading about breast cancer. Why did she have to get it at such a young age and so on? And then I realized there are lots of gaps. Then I said, okay, can I do something to it? Can I kind of, help, right, in the situation? Obviously, Bharti is gone, but maybe it'll help many more women. So I started a very small, I was a research manager, so I had this sort of opportunity to start exploratory projects in my lab. So I started a small one-member team. The second member was myself, to start researching on use of AI for breast cancer detection. And then fast forward 1.5 years, I thought we did get some early results which were very promising to actually innovate a new cancer detection solution. Of course, that was a time when my manager said, you are going to head the complete research in India for Xerox. And, but this project was actually not relevant to that company. So they said, you'll have to close down that project. Then, obviously, here I am. So I quit my previous job and said, we have to make this real. And that's how Niramai was born. I'm thankful for two of my friends and team members who joined me when we started Niramai. Niramai means being healthy. Some of you may be aware of Sanskrit line, Sarve Santu Niramayaha. Let everyone be healthy. That's our motto. It's a small startup now, close to 3 years old. January 1st, 2017 is when we quit the job and did this. We coined this name and we also made an expansion which is meaningful to the world in English, non-invasive risk assessment through machine artificial intelligence. So that's Niramai. And what we are attempting to do here is to non-invasively detect multiple health risks using AI, because that's what I know. And the first problem that we are attempting to solve is, as I mentioned, the one which motivated me to start this, which is breast cancer. Incidentally, breast cancer is one of the largest cancer killers in women. 500,000 women die every year because of breast cancer. The unfortunate thing is that they don't need to die, because breast cancer is completely curable. 95% survival is possible, and it is shown and seen in many countries. However, in India, the survival rate is 50%. Every alternate lady detected with breast cancer is dying today within 2 years. How do we change this? Why is this happening? It's all happening because, one, of course, people are not aware. It's such a common thing nowadays. It is 1 in 17 in the world, 1 in 7 in the US. The recorded number is 1 in 25 in India who are likely to get breast cancer in their lifetime. Early detection is extremely key, but still they wait for a huge lump to be seen or felt before they even come to the hospital or talk about it. Regular screening is very, very important. In addition, there are lots of other problems. Affordability, accessibility, of course, will be one of the main things, like any other preventive solution or general healthcare test. In addition, globally as well, women under 45 years of age do not have a test that can be used for screening in a very safe way. The most common method used for breast cancer detection is called mammography, which is an X-ray of the breast. And can you imagine? It is cancer detection using X-rays. So if you want to detect early, you cannot go every 6 months, every year to get a check done like you would do a glucose check, blood sugar check, because overexposure to cancer can actually cause cancer just because of the test. That is the only test that's available, and that only works on above 45 years of age. So that is the scene. And we said we want to change this scene. And obviously, we didn't want to use X-rays. So we started using a new method of sensing called thermal imaging, just measuring the temperature variations on the chest and adding machine learning on it. So we came up with this solution, which today detects malignancies, which are cancer, 4 mm in size, as opposed to 2.5 centimeters, that is 25 to 30 mm, which is what is getting detected today. Size indicates stage, as you would guess. So we are talking about stage 0 detection of breast cancer, and doing it in a way that it is extremely privacy conscious. Nobody likes to disrobe in front of the doctor or technician and so on. So this is a no contact, no touch, no see. Nobody sees the person during the test as well. There is a booth, the lady enters, she comes out after 15 minutes and her report will be ready. Completely automated using the software. No radiation, we just measure the temperature variations on the chest. And it does work for men under 45 years of age. Unfortunately, 17-year-old who is cancerous is somebody that we were able to detect as well as a 92-year-old who came into our camp and she was fine. So this is the whole gamut of age groups that can be detected, that can go through the screening. And of course, we made it more affordable and accessible. And I can talk more about it, but here is the solution. Now, quick look at how the solution looks and what is the experience, and a bit about the technology if there is interest. So that's a small device, which is between the two girls there. It's just like a tripod, a camera that can be placed on the tripod. The device itself is not ours. It's just a simple infrared imaging device that you would use for surveillance purposes, defense purposes. If you have seen the Uri movie, where you will see all of these sort of, Indians finding Pakistanis across the boundary and so on. So this is the type of just measuring the temperature. So outside temperature is -2 degrees. The person's temperature is like 37 degrees Celsius. So you will actually see the difference because one will be red and another is yellow. So that's kind of imaging device we use, but we use it inside a hospital to detect cancer now. And this can also be used by simple skilled people like nursing people that you see there. And you don't need a doctor to screen. That means it can actually scale. And not just in hospital, we can actually do it outside in screening camps. We also have support from Rotary, where they helped us create a bus called Pink Express, where we actually take this out to rural areas as well. The images that you saw were very much similar to like your airport heat map that you see, right? It's very similar to that. So ladies are okay, to get these kinds of images as well. So the technology we've invented is called thermalytics, and this is what we call it, thermalytics. And it's a combination of thermal imaging and artificial intelligence. And like I briefly mentioned before, we do this thermal imaging, and we have developed a software which analyzes these thermal images to figure out where can these abnormalities be, and then generate a report automatically saying what's the likelihood that it can be cancerous. And this is novel enough, made in India. We have 9 granted US patents and 1 Canada patent. I met a Canadian gentleman here, granted. And so it shows it is unique globally. The core innovation is like, what's new? Why can we detect cancer with a thermal imaging, right? And I'm sure many of the techie minds here will be thinking about it. So what happens is when there is a cancer cell, it divides at a much abnormal rate, and that results in higher metabolism and so higher temperature at the point. As well as the blood flow to that region would be very high, and so it starts showing different thermal patterns around it as well. And that's what a thermal imaging, high resolution thermal imaging device can catch. We actually measure 400,000 temperature points per person. However, every cancer may be red, but every red is not cancer. So if you start like just looking at red spot and saying somebody's cancerous, you will call 60% of the ladies as cancerous. That's where the catch is. And that's why, though FDA had said, yes, this can use this method for cancer detection, it was actually a method that was allowed in 1984 itself. It is not in practice today, not much in practice at all, because of this very reason of false positives. And that's what we change with machine learning. And a lot more stuff here. We have new methods of detecting blood vessel activity and so on and so forth, because of which we can call this as a computer-aided diagnostic methodology where women come in and out comes a PDF report. Of course, it can go to a doctor, the doctor reviews it and certifies the report, looking at other physical conditions and so on. A lot of papers and also clinical publications showing the efficacy of the device and the solution itself. So far, we have done about 15,000 women screened with this, and we've been able to actually go to remote places in different parts of Karnataka. We would really love to partner with Kerala and enterprises here to actually bring it to this state as well. And the business model we employ is just give us a room, set up the whole thing, train, and get the solution going from next day, and also monthly, weekly camps, and so on and so forth. It's now used in Maharashtra government, Karnataka, as well as Bangalore, all government hospitals in Bangalore approved, and we've actually won a lot of awards thanks to the ecosystem, extremely supportive. And one slide I want to leave with is this one. This is the top 100 AI startups in the world, and the only one from India which made it ever to this list is Niramai. Thank you so much. And this is the team that made it happen. I'm here just to guide them, and I'm here to represent the whole team here. Thanks a lot, and happy to collaborate with anybody here.
Thank you.
Any questions? We have 1 minute.
Yeah, what is the success rate of your diagnosis vis-a-vis X-ray for detection?
Yes. We have actually published 6 publications where we have compared. The latest one, I would say, was presented last week in a summit called Breakthrough Summit in ASCO in Thailand, which is American Society of Clinical Oncology. And there, with about 800 patients, we show that in asymptomatic patients, we have 100% sensitivity and 93% specificity. Symptomatic, both sensitivity and specificity are over 90%, 85, 90%, yeah. And mammography, we perform better than mammography, yeah. Especially in dense breasts.
Any figures there?
67% sensitivity in asymptomatic is, yeah. Thank you.
Does this also support other cancers?
Good question, yes. The technology can detect many cancers which are closer to the skin, like 5 centimeters from the skin, what are called carcinomas. Soft tissue can be detected. Because we are a small startup, we are starting with 1, and then we plan to extend, if everything goes well. Not just for cancer, it can also be used for several other type of abnormalities. Bill Melinda Gates Foundation grant for detecting river blindness, a completely different type of disease which is based on blood vessel activity in Ghana. So that's the other side. We are actually trying to experiment to see the limits of the technology itself. But definitely it requires a lot of collaboration and teamwork to make it happen for the other diseases. Thank you.
Thank you so much.
Thanks a lot.